So we move into final part of topic of differentiation, part C, and this part is application of differentiation, a very important application, which is to find maxima or minima of a function. So let's proceed, and we'll help this topic with we'll understand this topic with the help of example on instantaneous velocity. Suppose this is the equation given. Y is given as y is equal to 20t minus 5t square. And typically what we use, the t denotes time in second and y denotes position of a particle. So this equation defines motion of a particle with time. And since it is given in terms of y coordinate, motion is taking along y axis. Mathematically, if I have to look at, y is defined as a function of time. So y coordinate changes with time. So if this equation is given, from this equation, I can prepare a table like this for different instances of time. If I substitute different value of t here, I can find the position. So like this, you can prepare a table. So whenever equation is given, we can prepare a table. And once you prepare a table, we can always draw a graph. So whenever a function is given, we can plot a graph for it if there are only two variables involved. Okay, so this is what is given here. So here y is changing with time, and instantaneous velocity. So instantaneous rate of change of y with time, which is written as dy by dt. So what is dy by dt? Dy by dt is rate of change of y with time. And since the dt's time interval is very small, it is instantaneous rate of change. And that is called instantaneous velocity. So whenever a position time function is given, a derivative of position with respect to time give you instantaneous velocity. So this function, if I differentiate with respect to t, we get velocity. So let's differentiate. So dy by dt, substitute the value of y, this expression, instantaneous rate of change of y with time, which will give you velocity. So let's differentiate. Very simple derivative. So what is this term here? Rate of change of y coordinate with time is equal to velocity in y direction. That's why I use the suffix vy. And what is this equal to? Let's differentiate this part here. And very simple differentiation, it is equal to 20 minus 10t. So we started with position as a function of time. If I differentiate, we get velocity as a function of time. So again, we can have another mathematical equation. This was plotted here. Similar way, we can velocity as a function of time also can be plotted. And this is very simple relationship. It's a linear relationship. It will be a straight line. So whenever it is linear form, it will be straight line. It can easily be plotted. So this is where for different value of time, we can calculate velocity and we can plot it out. So we got this velocity. So velocity is a function of time. Okay, let's proceed further. So what we have from the previous sheet here, this was given. On differentiation, we obtained this expression. So we have position as a function of time, which is plotted here. Position as a function of time. This side is t in time in seconds. So what do we call this? A position time graph. A similar way, we can plot velocity time graph. And this is this y-axis, we have velocity, x-axis t, same range here. Since this is from 0 to 4 seconds, this is also 0 to 4 seconds. So what we notice here, where from this equation has come? This equation has come from here. Similarly, is this graph also? So this expression is a derivative of this function. So it is related to this particular expression. Similar way, this graph here, we see this brown line. This is a plot here. This is the graph of this part of the equation, velocity time graph. This is dependent on this particular graph. How is it is related? So mathematically, we said this is a derivative of yt function. In terms of graph, how do I relate these two? This also we can relate. So how are they related? So basically, derivative means what? See, derivative is obtained by drawing a tangent. Slope of tangent at any point gives its derivative. So this, what is this term here? So we can say here, so same thing if I have to state in terms of words, what I'm saying now. Slope of tangent to yt graph. Slope of tangent to yt graph is what? What is slope of tangent to yt graph? It's a derivative. So slope of tangent to yt graph is nothing but derivative. Will be equal to ordinate of vt curve at the same instance, which will give you velocity. So let's understand what is happening here. So this particular statement, let's understand in terms of simple example. But let's see what it means. How this graph can be arrived at from this particular graph. So let's see that one. Let's take example time is equal to 1 second. So which instance of time we are talking about? Yeah, time t is equal to 1 second. So at t is equal to 1 second, this is the y coordinate. At time t is equal to 1 second, where was the particle? The particle was at a y coordinate of 15 meter. If we say the y axis in the vertical direction, it was a height of 15 meter. Okay, so if I draw a tangent at this point, on this curve, I have drawn a tangent at which point? At equal to 1 second. So once I draw a tangent, I can find the slope. I can choose any 2 points when I drawn the tangent, and those 2 points, the delta y will give you delta y by delta t, will give you the slope. So if I draw a tangent, find the slope. This slope, what I calculate, is related to this graph here. How it is related? Again, I take this point here on this point, and so this is the y coordinate. And what does the y coordinate gives here in this graph? Y coordinate gives you y coordinate at t is equal to 1 second gives you velocity at 1 second. So this y coordinate is equal to slope of the tangent here. That's what we mean. So slope of the tangent at of yt graph at any instance of time is equal to ordinate of vt graph at the same instance of time. That's how these two are related. So what are things that we notice here? See, up to which point is the velocity positive? See, anything plotted on y-axis is positive when it is above x-axis. So this region here, velocity is positive, and here the velocity turns negative. And same thing we can understand from the graph also. When I look at this graph here, until this point here, see, if you look at any part of this is going up, slope is positive until this point, and from here the slope becomes negative, and slope gets steeper and steeper. Same thing is reflected in this plot also. So until this point here, slope is positive, this part, so 0 to 2 seconds, slope is positive and decreasing. So here also velocity is positive and decreasing. What happens between 2 to 4 seconds? 2 to 4 seconds, what is slope is negative, but slope is getting steeper. So here also velocity is negative, but magnitude of velocity is increasing. So understand these parts well. See, understanding of graph helps in understanding physics in a great extent. So try to make sure that every sentence I have explained is well understood. So if the particle move, so when we look at the graph, this is, suppose somebody says, people look at this graph looks like a parabola. And which kind of, what is this plot here? This is position time graph. And many times student gets confused. Actually, the particle is moving like this. Is the particle moving along this path? Is the particle moving along the curve? The particle is not moving along the curve. It is, this graph is showing something else. So is the particle moving along the curve? No, particle is not moving along the curve. It is moving along which direction? Particle is only moving along y direction. This equation tells you only y coordinate is changing. X coordinate is not changing. So don't confuse by this with yx curve. It doesn't tell you position of, it is, particle is not moving like this. This graph gives you value of a y coordinate of the particle at different instances of time. So from this information, if I ask you what is the maximum height the particle reaches, can we easily identify? See here, if I ask what is the maximum height, most of you should not have any difficulty in identifying what is the maximum height here. Maximum height means where the y coordinate is maximum. Can you identify the point? Should be easy. So all of you can do it, pause it, do it, and check it. And when it reaches maximum height, let's read this part again. What is the maximum height? And what is the slope of yt graph? This yt graph. So when it reaches maximum height, what is the slope of tangent drawn at that point? What is the slope to yt curve at the instance height is maximum? Can you find an answer for both? Okay, let's see. Okay, how do we do that part here? Okay, so this is something. So let's find an answer. What is the maximum height and what is the slope of yt graph at the instance height is maximum? So identification of maximum height. Number of ways I can do it. One way is, this is something at different instances of time I can find value of y. So here also I notice where is the y maximum? At t is equal to 2 seconds, y is maximum, which is equal to 20 meters. So by plotting by calculating value of y for various value of t, I can find out for where does it becomes maximum. If I plot a graph, it becomes easier. Where is the y maximum? Yeah, pretty easy. Y is maximum. Can you visualize? So when we talk about y becoming maximum, when this equation is given, graph is given, can you visualize this motion of this particle at an interval of 0.5 second? What an interval of 0.5 second means? Suppose I have a camera. You would have seen this kind of different frames. And you would have seen, we can say anything object is moving, we can click photograph at definite interval of time. So suppose I take a picture of this particle every half a second. What would picture look like? So can you visualize this motion? What is happening every 0.5 seconds? So this gives you y coordinate. I think you should try and do that. And pause, do, and check. Let's do that. How do we visualize this one? So where's the particle at time t0? It is here. So I will just click, I will keep on clicking every half a second, see how the particle will move. So where would the particle will be at half a second? 8.75. At 1 second, it will be 15. So how would it look like? It will move on this axis only. This is how it will look like. Just pay attention how it does look like. Okay, 1.5, 2, 2.5, 3, 3.5, 4. That's how the motion is taking place. So this motion is represented by this graph. So what you understand here, see, look at this. Every half a second, here the gap was more, displacement was more. Here displacement becomes lesser, lesser, even lesser. And then afterwards, it becomes, displacement becomes downwards. So if I have to define motion of this particle, this is the wording I can use. What is happening as it going up? It is progressively, it is slowing down. And then comes to momentary rest. When it reaches top, it is a state of momentary rest. And then after coming to momentary rest, it reverses its direction and falls with the increasing speed. So as it starts falling, the speed keeps increasing in the downward direction. So that's the kind of motion, and some of you can easily identify. This is the similar to motion of a particle thrown vertically upwards. So that's the motion which is taking place. And we can understand when you talk about momentary rest. What instance is coming to momentary rest? At t is equal to 2 seconds, this is a point when it comes to momentary rest. What does momentary rest mean? Let's understand that point also. What does momentary rest mean and how do we understand that part? Okay, let's do that part also. So here y is maximum. When is the y maximum? This is a point where y is maximum. And you know, if I draw a tangent at this point, what is the slope of the tangent at this point? So y becomes maximum when slope of tangent is 0 or dy by dt is 0. That's important point. Here y is maximum. See, y is changing with time. Y is a function of time. So at when does it becomes maximum? When dy by dt is equal to 0. Or it becomes maximum at a point where if I draw a tangent, the tangent has 0 slope. And we'll understand. And this is general condition for any quantity varying to become maximum or minimum. Even minimum also similar thing happen. We'll see in the next slide. So this is general condition. Any quantity y which is varying with t, it becomes maximum or minimum when dy by dt is equal to 0. And that we can visualize from the graph. Where do we understand? Yes, we can do mathematically, but in terms of graph also we can understand this is a point where it becoming maximum. And maximum, if I draw the tangent, the slope of the tangent is 0. That's the important point. So let's understand what is happening this side. If I look at this part of motion, motion from 0 to 2 seconds. How do I define this graph in terms of slope? Slope is positive. And is the slope increasing or decreasing? See, if I assume that if you're walking from here or driving your car here, what is happening to the slope? Slope is decreasing. So this graph slope is positive, but slope is decreasing. What happens beyond this point? Beyond this point, from 2 seconds to 4 seconds, slope is negative. So any point you draw tangent, slope is negative, but magnitude of slope is increasing. It is becoming steeper and steeper. That's the shape of the curve. That's how we define slope. And it is not too complicated. I think simple as simple definition. Slope is positive. So whenever slope is positive, so again, to come back to this point here, why has dy by dt has to be 0 at maximum? That's another way, another logic we can understand here. Let's see how we understand that logic. See, suppose I draw a tangent at this point. Here the slope is positive. Slope is positive means it is increasing. So if compared to this point, I've drawn the two. So if a slope is positive, if I choose any point later than this particular point, so at any instance later, if slope is positive means quantity is going to be higher. That's what he said. If slope is positive, it implies that quantity is increasing. A later point will be higher. So it means if the slope is positive, any point where slope is positive, it cannot be maximum. Same goes with the slope negative. Let's look at which point slope is negative. So suppose I take a point here. At this point, slope is negative. It means quantity is decreasing. It means if I take another point just before this, if slope is negative means quantity is decreasing. So compared to this point, if I take a prior point, prior means on the left hand side, this point will be higher. So this point also cannot be maximum. So any point where slope is positive or negative, that point cannot be maximum. Because if slope is positive, a later point will be higher. If slope is negative, a prior point will be higher. So where does the maxima happen? Where the slope is zero, where the quantity is neither increasing nor decreasing. That's the point where maxima occurs. So what is the general condition? This is something we understood for y. But in general mathematical sense, suppose that t I represent with quantity x, it is yx curve. So whenever quantity y is a function of x, which means when x is changing, y is also changing. So if y is changing, it may reach a maxima or it may reach a minima. What is the condition which will, what condition will determine maxima minima condition? For maxima minima to happen, for y varying with x, dy by dx has to be 0 at that point. So then only maximum minima will occur. So when dy by dx is equal to 0, it implies slope of tangent at that point is 0. Rate of change of y is 0. It means quantity is neither increasing or nor decreasing at that point. That's where the maxima occurs. It can be understood from graph. It can be understood from the slope of mathematical explanation what I've given here. And this is important point to understand about maxima or minima. Because maxima minima is something very important in competitive exam also. Many times questions are related to finding maxima or minima. Right. So, so let's take one more graph here. Previous graph only had a maxima, and we talk about local maxima or minima. So now suppose this is yx graph here. When you look at this graph has some local maxima, local minima. Local maximum means compared to nearby point, the point is maxima here. And suppose I look at this point, compared to nearby point, this is a minima here. Similarly, you'll find a maxima here also. So again, maxima minima for yx function. Suppose this is a graph plotted. Let's look at one more condition here. So wherever slope, see if I draw tangent at this point, slope of tangent is 0. At minimum point also, if I draw the tangent, slope is 0. So when dy by dx is 0, it indicates that point is either maxima or minima. Now, if graph is plotted, I can easily identify this one is a local maximum. Why I call it local maximum? Because there may be some other point higher than this, but it may occur not in the nearby space. And this one is a local minimum. Local minimum. Now, both cases, dy by dx is 0 at this point also. And dy by dx is 0 here also. So mathematically, if I don't plot the graph, how do I figure out of these two, where dy by dx is 0, which is maxima or which is minima? Is there a difference? See, visually you can see the shape of curve is like this where maxima happens. Shape of curve is like this where minima happens. So this is in terms of graph. Can we find a mathematical condition to define local maxima, local minima? I have drawn 3 tangents here, which itself is a hint. Let's understand condition for local maxima, local minima. How do you find? So dy by dx 0 indicates, so what does this imply? It implies it is maxima or minima. So in this case, in this graph, there are 2 local maxima, 1 local minima. This we can identify when graph is plotted. And slope is 0 at all maxima or minima value. So what does dy by dx indicate? Dy by dx is equal to 0 implies either maxima or minima. We also call extremum points mathematically. Okay, so for maxima or minima, this is a condition. First derivative. So yx function, when you take first derivative, when we equate to 0, we find the condition for maxima or minima. Now, what you notice, see what is happening here. So what is the condition for maxima here? See, as we move in this direction, as we move in the increasing x direction, slope is positive, it becomes 0 and slope becomes negative. So what is happening to slope here? So in the region around local maxima, what is happening to the slope? It is becoming from positive to negative. For maxima, slope changes from positive to negative. If anything changes from positive to negative, is the quantity changing? Is it increasing or decreasing? Suppose +2 becomes -3. Is there increase or a decrease? Anything positive becomes negative, there's a decrease. So, or the slope is decreasing. So that's the condition. Slope decreases in case of maxima. What is happening to slope here? See, when you look at this point, here the slope is positive. Here the slope, here the slope is, I'll just correct this one. So here left hand, this point, slope is negative. Here the slope is 0 and the slope becomes positive. So what is happening to slope for minima? Slope is increasing. That's a condition for minima. And this condition need not be memorized. If you can visualize this graph, which clearly indicates maxima, minima, and if you understand how the slope is changing very easily, you can have a kind of visual understanding of maxima and minima. So let's write the second condition. So what is saying? Suppose the previous case I have shown that even we can plot each point. Suppose each point each value of x, I can calculate slope. So I can plot another graph which indicates slope and x. So if this particular point, what is slope? Suppose I take this point. Slope at this point is 0. And what is slope of this point? Slope is positive. So left hand side slope is positive and right hand side slope is negative. So if I plot slope versus x, this is how it will look like for maxima condition. You know what is happening? The slope here, this is maxima. And what will slope look like? This is slope is 0 at minima point. This is minima point here. This is minimum point. So what is slope on the left hand side? Slope is negative and the right hand slope is positive. So how is the slope varying for minimum? This is how the slope is. So this is the slope around minima. This is slope around maximum. And I represent slope with m. So when I look at this graph here, I forget slope. Now this graph, what is slope of this graph? This graph has negative slope, this part, and this part has positive slope. So let's understand what is. So this quantity negative slope, this is decreasing. This is decreasing slope, and this is increasing slope. So this is what you understood. Maximum condition, slope is decreasing. Minimum condition, slope is increasing. How do we write mathematically? What is condition of maximum? So anything rate of change is negative. Decreasing is, so what is decreasing? Slope is decreasing. M is decreasing. So I have written dm by dx. Rate of change of slope is negative. It means it is decreasing. This is a condition for maximum. Okay. This is condition for maximum, negatives, and for maximum. What is slope equal to? Slope is equal to dy by dx. So what is the condition of maximum? This is called second derivative. I could have written this also as d square y by dx square. This is second derivative. So first derivative gives you first derivative equal to 0, condition for maximum minimum. If I take the second derivative, if second derivative at that particular point is negative, it implies maximum. And if second derivative is positive, minima, it is increasing. It means second derivative is positive. For minima, second derivative is positive. So second derivative helps you find whether it is maxima or minima. And you can understand this one visually also. And you can, if you get a visual understanding, it will stay in your memory with less effort and you have better clarity, better understanding. So I'll take an example of this, how to find maximum minima mathematically. See, graph, it makes it very easy. Suppose graph was not there, only the function was given mathematically. How do we do that? Let's take example. Problem on maximum minima. So position of particle. So you can say y is given as a function of t. Don't even think of whether this position. The y is given as a function of time. And any function will have certain range which is where it is valid. So it is valid from where to where? From time minus 1.5 second to plus 1.5 second. You know, so typically we don't take time to be negative. Time 0 means when I press the stopwatch. So this motion is valid not only after I press the stopwatch, it is also valid before I press the stopwatch. So this I have taken just for illustration. Tip, normally we will not take t value negative as a valid one, but very specifically I have defined it to be valid here in this case. So this is what is given here. Okay, so let's see what are things we can learn from this equation. What are kind of problems we can solve. Now, for this, what is given here? Particle is moving along y-axis. Its position at various instances of time is given. This position is changing, and velocity might be changing. What we need to find the instance of time when the direction of motion changes. Can we find what are the instances of time between -5 to +5 1.5 when the direction of motion changes? Okay, let's do that. What a condition. So at the motion, what is direction of motion? What is direction of motion? How do we understand direction of motion? If velocity is positive, it is moving in the positive direction. So if positive velocity becomes negative, that will imply change in direction, or negative velocity becoming positive will imply change in direction. So what is change in direction? When the velocity becomes changes sign, when the velocity changes sign, and whenever velocity changes sign, you can see in the previous graph also. So when you look at this part here, this part velocity is positive and this part velocity is negative. So when does velocity changes time? When does velocity changes direction? See, whenever velocity changes direction, it will come to a state of momentary rest. dy by dt is equal to 0 means velocity 0. So typically a particle, whenever it reverses direction, it comes to momentary rest. Imagine when you are traveling the car also, if you have to reverse your car, you have to come to a momentary rest. Similarly, that's what we keep in mind. So time instant time when the direction of motion changes. At the moment the direction of motion in y direction changes, the velocity has to be equal to 0. So that's a condition for change in direction. dy by dt has to be 0. Okay, so can we find dy by dt? It's very simple derivative. This gives you vy. You can find this derivative. It comes equal to velocity comes this expression. If I equate to 0, the value of t which satisfies this equation will indicate time when the velocity was 0, and when the velocity was 0, the direction of motion of particle has changed. So can we solve this equation? It's quadratic equation. We'll have two values of t when which will satisfy this equation. If I solve, I get two values of t. It's equal to -3/5, which is within the given range, -0.6 and +0.33. The -3/5 and 1/3. So these are the two instances of time when this function achieves its maxima or minima. I can say another way, if I go to maxima minima, dy by dt is equal to 0 indicates the condition for maxima minima. So these are the two instances of time where it is achieving maxima or minima. But which instance is maxima, which instance is minima, how do I find? So which is local maxima, which is local minima? What is the way to find which is local maxima and local minima? First, I equated first derivative to 0. It gives you maxima minima time. To figure out which is maximum minimum, we have to take the second derivative. So second derivative is a derivative of derivative. So what we need to do, find which is maximum minimum. See, basically, if I have to plot this graph also, this is what we are doing mathematically. I could have, for a visualization purpose, if we had time and resources, we could have prepared a table, we could have drawn a graph also. From the graph, if I had to look at which are the instances which changes direction. So which is the point? Can you identify the point on the curve where slope is 0? Can you identify? See, look at this point here. At this point, slope is positive. So somewhere here, this is maximum point, local maxima here. And if I look at this part also, somewhere here, I see it is slope is 0. If I draw tangent at these 2 points. And here from this graph, so what has happened here? From here up to this point, slope of YT graph is positive. It means V is positive. From here to here, it is going down. Slope is negative, means V is negative. This is something I am doing it from the graph. And from here again, V becomes positive. From here again, slope is positive, means V is positive. So which are the instances direction is changed? This is the time. So if I drop a perpendicular, this is the first T1 when the direction of motion has changed. This is the second value T2 where the direction of motion has changed. If I do graphically, if I were doing, it is something little more than -0.5. It is roughly -0.6, which matches with this. And what is this point here? This is roughly 0.33, which matches with the solution. So same thing I can do in the graph also. So here, so if I have to graphically, this point is T1 is maximum. From graph, I understand that at minus 3 by 5, it achieves local maxima. At plus 1 by 3, it achieves local minima. Can we do mathematically also? Let's do it mathematically. How do we mathematically? We find the second derivative. So derivative of derivative. So again, we differentiate this term. If I differentiate the whole term again, I get 30t plus 4. So this is second derivative. So we find derivative at which 2 points? We'll find the value of second derivative at this point and this point. If it is positive, it is minima. If it is negative, it is maxima. So let's do that one. Sign of second derivative at these 2 points here to decide maximum minimum position. So let's first point t is equal to minus 3 by 5. I substitute this value in the second derivative expression. In place of t, I substitute minus 3 by 5. If I calculate this value, it comes to minus 14 negative. So negative value indicates maxima here. So it indicates, yes, these are the 2 points where maximum minima happens. This point is a local maxima and this point is a local minima. So that's a application of maximum minima and how to identify which one is maximum, which one is minima. It's a very important application. And again, make sure that every small bit is understood thoroughly. If required, go through multiple times, see that every bit is clear. So here also, okay. So this brings us to end of the topic of differentiation. Next session, will go through integration. So next topic in this series will be integration. So we'll stop here. Thank you.